Hello, Nick Leifker here, and welcome again to Operations Management. Now, we talked some about forecasting. We talked about what makes a good forecast. We talked a little bit about the various rules of forecasting. Why do we do forecasting? And what makes a good forecast. So now it's time to start talking about actual forecasting methods. Now, as I mentioned before, the time series forecasting that's the simplest method. And for all intents and purposes, time series forecasting is simply the application of the past into the future, into the near future more specifically. So what we're going to do is we're going to start by looking at some simple time series forecasting methods. We're going to look at naive forecasting, we're going to look at various forms of moving average, and we're going to look at exponential smoothing. Now, if you look in the book, there's a couple of different forms of naive forecasting. I go with the absolute simplest method available, and that is that with naive forecasting, history literally repeats itself. In other words, the forecast for this coming period is the same as the actual results for the most recent period to have finished. So if we had a case where we had sales of, say, 75 for the previous week, well, that means that our forecast for this week will be 75. So the forecast for this coming period is simply the actuals that we have just experienced. In other words, the actual result we have just gotten. So we literally expect history to repeat itself. Now, naive forecasting, it has its problems. One of the big ones is that if there is an outlier, if there is an odd individual week or an odd month, then what tends to happen is we tend to see those fluctuations in our forecast. And the problem is those fluctuations aren't necessarily a good predictor. So if sales are twice what we expect one week, then if we have a naive forecast, then we expect that same event to happen the next week. And sometimes that's the case, and a lot of times it's not. So because of this, what we generally do is instead of taking the most recent time period, as we do with naive forecasting, we look at the last 3 time periods, or the last 5 time periods, or the last whoever knows how many time periods. And this we call moving average. So the idea of moving average is that we take the average of the last 3 periods, or the last 4 periods, and the last 5 periods, however many periods we really want, and this becomes our forecast for the next time period. Now, this tends to be a lot less susceptible to fluctuations. It tends to be a lot less susceptible to these outliers that occur on occasion. So, if we've had weekly sales of 68, 73, and 69 over the past 3 weeks, then our forecast, by using a 3-period moving average, would simply be the average of those 3. So 68 plus 69 plus 73 divided by 3 equals 70. And so, as mentioned, moving average tends to be a lot less susceptible to fluctuations, which is why it tends to be used for simple cases. Now, sometimes we want to tailor some things. We want to perhaps give more weight to more recent events. That said, we don't want to simply rely totally on the most recent case, as we see with naive forecasting, so we may want to tailor our forecast a little bit. And how we can do this is with what's known as the weighted moving average. So what we do is we take the last several actual results and we weigh them differently. In other words, we multiply them by different percentages according to how much we want to use those particular cases in our forecast. So suppose we decide that we want a weight of 0.6 for the most recent week, 0.3 for the week before, and 0.1 for the week before that. Well, what we do is we take the weekly sales for the last 3 weeks, 68, 73, and 69 over the past 3 weeks, with 69 being the most recent, well, then the 3-period weighted moving average would be 69 times 0.6 plus 73 times 0.3 plus 68 times 0.1. And so this is how a weighted moving average works. It is the actual results for the last several time periods multiplied by the percentages that we give to those time periods. Now, there's also a method known as exponential smoothing, and the way to describe exponential smoothing is this. You take a forecast, and then you adjust it by how much that forecast is wrong, by a percentage of how much that forecast is wrong. So you take the forecast for one time period, you take the error of that forecast, in other words, how much was it wrong, and multiply it by some alpha, by some percentage. And this becomes our forecast for the next time period. So the forecast for the next time period will be the forecast for this time period plus this alpha, this adjustment, multiplied time by the actual minus the forecast for that time period. For instance, what we could do is suppose we have a forecast of 69 and an actual result of 64 for that week. So we were off by 5. Well, if we use an adjustment alpha of 0.4, then our forecast for the next week will be 69, the forecast that we just used, plus 0.4 times 64 minus 69, well, that equals 67. So we would have a forecast for this coming week of 67. Now, with these methods, you'll notice several things. One, that this particular set of methods only forecasts for the next time period. So we can't forecast long term. All of these are short-term forecasting methods. We can't forecast, say, a year from now or 10 years from now. We can only forecast for the next time period. Also, well, it handles some things well. If there isn't a lot of change in the value being forecast, it tends to handle things fairly well, but how often does that happen? We have things like trends, where we expect our results to increase or perhaps decrease over time. We have things like seasonality. So how do we handle these things? What happens if we know that we're going to have these changes in our results? Well, these methods tend to not work so well, which is why we tend not to use them so much. So how do we handle things like trends? How do we handle things like seasonality? Well, for this we're going to need some more complicated methods. So, suppose there's a trend in our data. In other words, we expect things to increase over time or decrease over time. Well, we generally have two methods. The first is what's known as trend-adjusted exponential smoothing, and the second is known as a trend line. Now, a trend line is simply a form of linear regression, and we will talk about that in significant detail. That said, a little bit about trend-adjusted exponential smoothing. For lack of a better way of putting it, well, trend-adjusted exponential smoothing, well, yeah, you could use it, I guess, kinda. That said, it's really not all that useful a tool. It does allow for exponential smoothing of both the increased trend and the forecast itself. So you have these two parts of the forecast. You have the forecast itself, and you also have a trend factor. In other words, how much do you expect it to increase? That said, trend-adjusted exponential smoothing is really not a good way to forecast using when there's a trend. It's usable, but there are better tools. A trend line is a much better tool. So, that said, we are going to talk a little bit about a trend line, how to make one, how to use one, and ultimately how we can come up with these to forecast for the future. That said, that we will talk about in the next video.